There are times that you're going to need to understand exactly why you're getting the results you are from your expressions. And we're going to need to understand the calculation sequence. Now this is also known as the order of operations. Now the good news is this is the same stuff that you learned in the 3rd grade or the 2nd grade, I don't know what. All I know is when I went to school, elementary school, we were pretty much dumb as dirt. We hit 1st grade, we didn't know half of our colors, we didn't know our alphabet, we didn't know anything. Back then they thought that you were better off to show up totally dumb and let them shape you the way you needed to be. And of course nowadays our kids are reading Homer and the Iliad and the Odyssey by the time they start kindergarten. All right, so anyway, I don't know when you learned this stuff, but it hasn't changed. I don't know what any of that has to do with C++, but anyway. So here's what it works out to be. Generally, multiply, divide, add, and subtract. So if you create an equation with some multiplication, some division, some addition, and subtraction all in there, and you just write it out that way, no parentheses or anything, the compiler will find the multiplication, do that first, then it'll divide, then it'll add, then it will subtract. Now, you don't want to depend on that, obviously, and there's one minor problem with C++ when it comes to order of operations, and that is what you learned in the 3rd grade still works, but there are many more operators. And I'm not even going to list all the operators. There's probably 30 of them. And we're talking about the not symbol, greater than, less than, greater than, or equal to, your increment and decrement operators, and on and on and on. So how do we make sure that a calculation produces the correct results and the results that we expected? Well, the easy way to do this is simply to make friends with parentheses and use parentheses to group things because, again, just like you learned in 3rd grade, I learned it in 3rd grade, you may have learned it 2 years before you started kindergarten. The innermost parentheses get handled first, and then you work out from there. So you always go to the innermost parentheses, then the next innermost, and the next innermost, and finally you work your way out. Now, there's another thing that you need to understand. In C++, there's always another thing you need to understand, right? Well, something else affects this, and this is called associativity. Now, I'm going to tell you about it here, but I strongly recommend that you go out to Google and just type in C++ associativity and read about it just a little bit. But associativity determines how operators with equal precedence are sequenced. All right? So let's do a simple example here. I'm adding 4 variables together, w plus x plus y plus z. Now, what's going to happen with associativity is that the plus sign has an associativity of left. All right, so it's left associative, and so it is simply going to go to the far left of the equation that has all the pluses and work its way out from there. And this is what it would look like if we use our parentheses. All right, so if we'd used the parentheses, we would have said w plus x. All right, get me a number here. Let's say everything's equal to 1. W, x, y, and z are all 1. So 1 plus 1 is 2, and then 2 plus 1 right here is 3, and then the result of all this parentheses, this one and these 2, right, is 3, and then we add that to z, which is 4. All right, hope that made sense. This equals 1, this 1 plus this 1 equals 2, and then this 2 plus 1 equals 3. All right, I probably made that a lot more complicated than I needed to, gave you too much information. Now, here's the thing you need to remember. Most operators have left associativity. However, there's just enough right associativity operators out there in C++ to surprise you sometimes. For example, the not symbol, the exclamation point, has a right associativity. The assignment operator has a right. Notice the plus, equal, or the increment. One of the versions of the increment operators has a right associativity. All right, so go out there, read about associativity just a little bit, and look at some examples of this. Better yet, go play with some examples. If you go back to the increment and decrement operators part 2, we did a little sample code out in Visual C++, you can use that very same program and just kind of play with some different expressions here without parentheses, and just make sure that they get you what you expected, and then play with using parentheses to change it. Now, an example of plus, it really doesn't matter. You could have added W and Z together and then Y and then X. It's always going to turn out the same. But when you start mixing addition and subtraction and multiplication and division, anytime you start crossing all those up, it can get kind of interesting sometimes. All right, so again, simple solution here: always use parentheses to make sure you get what you thought. Always check your results to make sure you're getting what you assumed you were going to get. And then you just need to be aware of associativity, because this can, again, when you least need it to. You're trying to deliver a project by Friday afternoon at 4:30, and sometimes around 3 o'clock you're going to recognize you got a problem. It's caused by associativity. It's caused by a calculation giving you something you didn't anticipate, and there goes your afternoon, there goes your sanity, there goes everything. All right, so make sure you pay attention to this. It's one of those little things that looks simple but can come back to bite you really bad. So that's calculation sequence and what you need to understand about it. In an earlier part of the course, we've already talked about the fact that when you create variables, you have to assign those variables a data type. And in this video, we want to talk about what happens when the type of variable that you created, or the type of object, or the type of type, if that makes sense to you. Don't worry about it if it doesn't. What happens when that type that you've created needs to be changed and we need to convert it to another type? Well, we're talking about an area of programming called type conversion. Now, this is all about apples and oranges, okay? Calculations can only be performed on values of the same type. If I give you a word problem where I have 2 apples and I buy 2 more apples, how many apples do I have? Okay, I have 4 apples, okay? If you got that, you're doing pretty good. Now, if I have 2 apples and I buy 2 oranges, how many apples do I have? Well, that's kind of a stupid question. I only have 2 apples. I now have 2 oranges to go with them. It's very hard to add those. But when the values aren't the same type on my variables or any other type, I now have an issue, just like my apples and oranges. Type conversion must occur. In other words, apples have to become oranges, or oranges have to become apples, or they both need to become somehow the same thing. All right? Here's a solution to the problem with the apples and oranges. All right? It's kind of hard to make an apple become an orange, or to make an orange become an apple. But if both are typed as fruit, now we're okay. All right? So I have 2 pieces of fruit. I buy 2 more pieces of fruit. Now how many pieces of fruit do I have? I have 4 pieces of fruit. Do you feel like you're on Sesame Street at this point? So that's what's going on with conversion. Now let's take it into the C++ world. There are 2 types of type conversion that you can employ in C++. There is what's called implicit conversion, and then there's explicit conversion. All right? Now let's take a look at implicit conversion first. With implicit conversion, the compiler sees, hey, wait a minute, dude's trying to add apples and oranges and he can't do that. So the compiler decides what will be changed. So the compiler says, okay, I'm going to change dude's oranges to apples, and then I'm going to add them all up as if they're apples. All right? Now, here's what's really happening in the background. The compiler doesn't actually change your original variable type. So you got apples and you got oranges. It sees that you can't add apples and oranges, so it says, okay, I'm going to change the oranges to apples, but I'm not actually going to change the oranges. I'm going to basically make a copy of them, call them apples, and use that, and then throw the fake apples away once the expression's done. Okay, so that's exactly what it does. It makes a copy, works with the copy, then discards it when the calculation is completed. Now here's the problem. This can produce some surprising results. In other words, sometimes the compiler will convert something for you, and then it gets kind of interesting. All right, good example, signed and unsigned integers. If it converts a signed integer into an unsigned integer, it could drastically change the numbers that you're looking at. All right, So now let's talk about explicit conversion. Now explicit conversion is where we don't want to trust the compiler to make the decision, or sometimes the compiler looks at it and says, hey, wait a minute, clown, you've got apples. Compilers don't use words like clown, but in our case they do. Wait a minute, clown, you've got apples over here and oranges over here. I can't make an orange become an apple. And so the compiler would just say, okay, that's it, I'm not working. And the compilation breaks. But you could go in and explicitly tell the compiler what you want to have happen. Sometimes you don't want the compiler making your decisions for you. Sometimes it can't. So you explicitly force a conversion from one type to another. Now this is also known as casting. And you will hear and read out there about casting value types or casting types. This is what they're talking about. Now here's an example of this. The static cast. Notice static underscore cast, and then inside these little brackets, I call them HTML brackets, the type you want to cast to. And then in parentheses the expression or the variable that you need to provide the casting functionality on. Alright? So what I want to do here is, let's stop this video. This will be part 1 of type conversion, and join me in part 2, and we'll continue this discussion and then take you just a little bit deeper into kind of some of the specifics of type conversion in C++. Welcome to type conversion part 2. Now in part 1 I kind of laid the basics out for why we need type conversion, kind of how it happens in C++, and in this video, part 2, I want to dig just a little deeper. Now in C++, there are 2 main types of type conversion that we can have, or 2 main kinds. And we'll go ahead and start to call it what you're normally going to see it. You'll seldom see the word type conversion, you will see casting. So there's 2 ways to cast a particular object to a different type. There's static casting, and then there's dynamic casting. And again, when we talk about casting, we're simply talking about type conversion. Now let's talk about static first. When I do a static cast, I'm going to use the command, notice the keyword here, static underscore cast, all run together just like that. Then inside these little braces, I'm going to put the type that I want to cast to. So this is what I want it to be, and then inside the parentheses the expression or the variable that I want to cast. Alright, and here's a good example. I'm going to do a static cast right here, and I'm going to set the variable a to an integer data type. So I'm casting a to integer. Now it seems a bit funky and it looks like it's out of order. Wouldn't it have been better to have a and then int? We'll talk about that in just a second. But this is how we would take a, it might be a long or something like that, and we're going to cast it to an integer. Alright? Now what happens with static casting is the compiler checks the cast when the program is compiled to make sure that it makes sense, that it can deal with it, that everything's okay. Now once the compilation has happened, no further checks occurs, meaning if I get past the compilation without a problem, then nothing else is going to check this, and it will get cast when my program's executing. And if it causes a problem, too bad. We checked it during compilation, and that's our only job, so we're done with it. Alright? Make sure you understand that. Then there's dynamic conversion or dynamic casting, and with dynamic casting the conversion is actually checked when the program is executing. Now a lot of times this is considered maybe a little more safe, it's a little more convenient to do static, but then don't just leave it there. There's lots of other reasons and situations when you want to use static over dynamic, but for now just understand the difference between these two. Okay? Now there are 2 more types of casting that I'm not going to go into here because I don't want to get too deep, but I'm just going to throw them at you so that you know about them, and you can go out and Google these and do a little bit of reading in your spare time. I know you got lots of that. And notice const, C-O-N-S-T underscore cast. This has to do with constants. That's as much as I'm going to say. And then there's reinterpret cast. And this one lets you kind of blow everything away and start over, if you will. All right? That's as much as I'm going to say about those. I just wanted you to know they're out there. Go out and that's your homework for this video. Go out and read more about those and see what you can do. Now, there is a type of casting in C++ that you need to be aware of, because you're going to see it and it will be a little bit confusing, and that is casting the way Grandpa used to do it. All right, well, maybe not Grandpa, but maybe coders just a couple, 3, 4 years ago. All right, earlier versions of C++ did casting a little differently. All right, they used this kind of syntax. All right, they put the type to convert to and then the expression. All right, now the expression, if it's more than just a single variable, would have been in parentheses also. So for example, to type the variable a to an integer, you would have typed int in parentheses and then the variable a. All right, now this is really cool. It's considered by a lot of people easier to write, easier to read, and all that kind of stuff, and you will still see it out there. However, this old style could be unclear in a lot of different situations. It could produce errors, it could confuse people, it could make the code hard to understand, but you will still see this out there. It was very popular. It's the way everybody did it and everybody got used to it. There are still some situations, if you're using MFC and some other things, that works better. We don't want to get into all that, but generally, notice the word generally, you should use the new style. You should use static or dynamic. This makes it a little more explicit in the way we write it. It makes it a little easier to understand what the programmer's trying to do, what they're intending to do, and it can save you some time on the troubleshooting side. All right. So anyway, that's part 2 of type conversion. There is a lot going on here. I would strongly recommend that you go out there when you feel comfortable and dig into type conversion a little bit more. But for now, that's the basics. That's enough to get you going and keep you safe. All right.